My dear student, welcome to School of Fundamental Sciences, SOFS. I deliver some fundamental concepts of physics, chemistry and mathematics for JEE Main and JEE Advanced. It will give me great pleasure if you enjoy this concept. Now, last part of applied differential calculus, that is called the idea of differential. It is also very useful concept. Let us see. Now, if we have a function x as a function of t, then with the help of idea of differential we can find the small change of x for the corresponding small change of t at x at the moment of time t. How? Let us see. For x equals to ft we have dx equals to dft, but dft cannot be operated in this way. It is a function of t, so we need ddt operation. So apply chain rule, ddt of ft dt. So dft remain as dft, but we have applied chain rule, ddt of ft equals to ddt of ft dt, chain rule. Now it can be operated. Where dx is the what? Small change of x for the corresponding small change of t, that is dt. Yes, for dt at x and at the moment of time t. This implies dx equals to ddt of ft. We can also denote this by f dash t. Ddt of ft also we can write f dash t or f prime t. So we can write dx equals to f prime t dt. So in this way you can find the what? The small change of x, that is called dx, for the small change of t, that is called dt, at the moment of time t at x, instantaneous situation. At the instant t is equal to time t is equal to t, we can find the small change of x, that is dx, for the corresponding small change of time dt. You see some example, then you can realize. For example, number 1, let x equals to cos omega t plus phi, where omega and phi stay constant. Then what is dx? Dx equals to d of cos omega t plus phi, but not possible. So ddt of cos omega t plus phi into dt, chain rule. Now ddt of cos omega t plus phi equals to what? Standard result, minus sin omega t plus phi, chain rule. Again ddt of omega t plus phi dt, that we have done in differentiation. Here just you consider omega t plus phi equals to z. So ddt become what? D dz cos z, that is minus sin z, into ddt of z, the ddt of omega t plus phi dt dt. So this equals to, now ddt of omega t plus phi is equal to omega, because omega into ddt of t 1 plus ddt of phi 0, because phi constant. So from here we can have omega, so minus omega sin omega t plus phi dt. So you see, for this function we have obtained small change of x, that is dx, for the corresponding small change of t, that is dt, at time t. Another example, x equals to lambda by mu 1 minus e to the power minus mu t, where lambda and mu are positive constant. Also again we are going to find dx. So dx equals to same dx equals to what? D of lambda by mu 1 minus e to the power minus mu t, but not possible. Since it is a function of t, we must apply chain rule, ddt of 1 lambda by mu into this into dt, chain rule. Now this equals to what? Lambda by mu constant taken out, ddt of 1 minus e to the power minus mu t dt. This equals to lambda by mu into 0 minus ddt of 1 means 0 minus ddt of e to the power minus mu t dt, and is equal to what? Lambda by mu minus ddt of e to the power mu minus mu t means what? E to the power minus mu t into ddt of minus mu t, chain rule concept, into dt is equal to lambda by mu. From here we have minus mu. So minus mu and minus, so minus plus, so mu e to the power minus mu t dt. Now mu cancel, lambda e to the power minus mu t dt. Now in this concept, you see differential concept, not only we can find the small change, we can also find the error. Also in integral calculus we will use differential concept. It has wide application also. Now you see another practical problem. SP 17. A particle is moving along x-axis with the law given x equals to 5 meter per second square t square. We have to find the small displacement dx at a particular moment t is equal to 2 seconds for the small time interval dt. The first method without calculus, that is called old math, and after that you see calculus concept, that is a new math. X equals to 5 meter per second square t square is the initial. For the final, x plus dx, when t final means t plus dt, there I have set x equals to x plus dx, 5 meter per second square, t is replaced by t plus dt whole square. Now subtract. So x plus dx minus x is equal to this minus this, that I have written. X is cancelled, dx is equal to what? 5 meter per second square taken common. So we will have t plus dt whole square minus t square. And then a plus b whole square formula, t square cancel out, 2t dt plus dt whole square. Now you see the, yes, old math concept, dt square, dt tends to 0, you know. So if you have dt square, dt cube, dt to the power 5 and so on, they are much smaller than the first term also. And since they are connected by plus sign or minus sign, so it can be neglected. That is simply you put dt plus dt square equals to 0. If it is connected by plus sign, minus sign, be careful. So it is connected by plus sign, so dt square must be 0. If you have plus dt cube, obviously 0. If you have minus dt to the power 4, obviously 0. So ultimately we will have 5 meter per second square into 2t dt. Yes. Now this will be equals to what? 10. 5 to the 10 meter per second square t dt. Now find dx at t is equal to 2 seconds for the small time interval dt. Come here. So put t is equal to 2 seconds. So we will have what? Dx equals to 10 meter per second square 2 second dt. This will be what? 20 meter per second. You see dimensional rearrangement also you see. Meter per second square into second, so meter per second you see. So 20 meter per second dt, this is the answer. So it is the small change of x, that is called dx, for the corresponding small change of time t, that is dt, when t is equal to 2 seconds. Similarly, you can calculate when t is equal to 3 seconds, when t is equal to 4.5 seconds and so on. Now you see second method, that is called new maths, that is called concept of calculus. X equals to this. So what is dx? Already explained, you see dx equal what? It is a function of t. So chain rule, ddt of 5 meter per second square t square into dt. So dx equals to d of this, dt cancel out. So dx equals to d of this. But d operation not valid. So since it is a function of t, we must have ddt operation. So ddt of this equal into dt. Chain rule. So 5 meter per second square taken out, ddt of t square dt. Ddt of t square, you know, 2t dt. So you see 10 meter per second square t dt. Now same as before, put t is equal to 2 seconds. So you will have dx equals to 20 meter per second dt. Now next problem, you see error calculation. You see dx and dt, if you say dt is a small error for recording time t, so dx will be the what? Corresponding small error for the displacement x for x. So here also you see, in this way you can calculate the error, yes, in the time period t, if we have some error in measuring the length of the pendulum L. So you see, it is the time period capital T of a simple pendulum of length L is given, where G is a constant. That we have considered G stage constant. We have to find the percentage error in measuring the time period T when the corresponding error in measuring the length L equals to 1%. Let us see. T is equal to 2 pi over L by G given. Now it can be differentiated in this way. Base differentiation is a logarithmic differentiation. So take log on both sides. Log means ln, ln means ln means log to the base e. So ln t is equal to, it is a property of log. Ln, if you have a ln pq, it will be ln p plus ln q. Obviously p and q must be greater than 0, because log of 0 or negative quantity cannot be defined. If I say log x, x must be greater than 0. Log of positive number can be defined only, be careful. So ln pq is equal to ln p plus ln q, that I have written, you see, ln 2 pi plus ln L by G to the power half. Root over L by G means L by G to the power half. Then again another property you see, ln p to the power q is equal to q ln p, and ln p by q is equal to ln p minus ln q. That I have applied here. Yeah, half will come here, half ln p by q means ln L minus ln G. So this implies ln 2 pi minus half ln G plus half ln N. Ln 2 pi and minus half ln G, it is a constant, so it can be replaced by a constant C. So C plus half ln L, where C is equal to ln 2 pi minus half ln G equals to constant, because 2 pi constant, G also we have taken constant. Now apply the differential operation. So simply if we apply D, it will be D ln T is equal to DC. DC means 0, D half ln L. But in this way we cannot operate this, we can apply chain rule. So ddt of ln T dt, d ln T we can write ddt of ln T dt is equal to 0, half is taken out, ddl of ln L into dl. So ddt of ln T means 1 by T, standard result. So 1 by T dt, so dt by T equals to half, ddl of ln L is equal to 1 by L, so 1 by L dl, so dl by L. And these are called the fractional error. dt is the what? Error in reading time period T. dl is the what? Error in reading LLL, the length of the pendulum L. So dt by T is the fractional error in measuring time, dl by L is the fractional error in measuring length. Percentage error means 100 is multiplied. So ddt into 100% equals to half, dll into 100% percentage error. Now it is given half of 1%, it is given. So 0.5% is the what? Percentage error in measuring time period of the pendulum. Another application of concept of differential.